In that presentation, the first thing I did is I walked through what a measured launch was and how you um, used it with a DRTM, or how a DRTM was used to do a measured launch. And then I discussed a few points, which is at the end of the day, SRTM was already standardized. It was already being integrated into the major open source system boot related projects. And so what I was proposing is that we bring DRTM up to that same level of standardization and adoption. And then on top of that, we could then build an approach that would be a framework that allowed people to build SRTM and DRTM security solutions. And so what does that really make Trench Boot? Trench Boot is just a meta project, which is focused on building a cohesive capability across multiple external projects. The product of Trench Boot is not a releasable product. The product of Trench Boot comes in the form of patch sets that we submit upstream to other open source projects. And we're doing those patch sets, we're building these capabilities within these existing projects to provide a unified and interoperable approach to measured launch, both SRTM and DRTM. So when you've heard any of our past presentations and we talk about Trench Boot enabling framework for building security engines to perform launch integrity, this is what we're talking about. We're talking about making our system loaders and our system kernels work in a similar manner for measured launch, so that a set of libraries could be made for system implementers to use to build measured launch solutions that meet the needs of their use case. It will increase reuse and it'll unify how this is done. In doing that, we're also building a unified approach to doing a DRTM launch across all the major open source projects. And the reason why that's important is that SRTM launch it's static by its nature. It's pretty fixed on how it's done, right? Whereas a DRTM launch, it's by its nature is dynamic and can be done at any time during system runtime. And so there's lots of ways it could be started. And so what we're trying to do here is unify that so that way you can take any system loader and use it to do a DRTM launch of any kernel on any DRTM enabled CPU. Now, when that's all done, the success of this project is not measured by the number of releases we make or how often we make releases. It's measured by how many projects we're able to get this capability upstreamed into. And then as an ancillary goal of the project is that whenever possible, we want to influence the hardware and software ecosystems to unify around a common way of doing launch integrity. And so with all of that, with understanding where it came from and what it is, we can go into and look at what we're trying to do, where we're moving towards. And that comes in the form of this roadmap. When we sat down to build this roadmap, what we did was we took a look across both the hardware and software landscapes. And when we're looking at these, we basically said, okay, what is it that we're currently doing? What is it that we want to do next? And what are the just general things we want to see happen, whether it's done by us or somebody else? And so we collected all this together into a spreadsheet and we called it our roadmap, and we've published it here in our documentation repository. And so like I said, we built this spreadsheet up, and the spreadsheet has multiple tasks laid in there. And when we identified some of these tasks were things that we didn't know if ever would be possible. But there's still things we'd like to see happen. And these were our halo tasks, which we colored in a light blue, as you can see in the legend here. And then there's these things that we want to do, but there's a lot of roadblocks, a lot of hurdles that are going to have to be overcome to accomplish them. And these are the things that we refer to as having hard to fill dependencies. And these we shaded in yellow. And the remaining tasks, more or less, we viewed as things that were just a level of effort and would just take time to get done based on resource availability. And finally, when we were laying out the columns in these, the silos that you'll see in a moment, we put a time-based or a time factor to these. And it's a time factor in the sense that tasks that we put higher in a column means that these are things we want to see done sooner. And the things that we put down lower in the column is tasks that we foresee will be further down the road before they're able to be worked. And so with that understanding of how this roadmap came about and how things are laid out, let's start to take a look at it. So the first area we want to look at is the hardware space. And the hardware space is really more of an area where we would like to seek influence more than we would seek to make contributions. And obviously the reason being is that, the hardware space is owned by the silicon manufacturers and the OEMs and the device manufacturers. And so making contributions to them are less likely. There's less areas to do that, whereas providing input and asking for changes is more of what we would see in this area. And so with that understanding, we can move over here to the first two columns, which is the ecosystem and the supply chain. So the ecosystem and supply chain, the tasks in here, these are tasks that we already have elsewhere. We copy these over into these because these are not just tasks that we want to do. These are tasks that we are seeking for assistance from the ecosystem and for the ecosystem, the actors in the ecosystem to help promote and move forward. So I'm not really going to cover the first three in these here. We'll touch on them later. The one that is here is a research paper that is being discussed amongst a few of the contributors to discuss some of the areas around the AMD architecture and some things we'd like to see and some things we'd like to help with if possible. And so that brings us next to the silicon, where we're primarily focused on AMD and Intel. Right now, there's not a lot we have any big asks from Intel at this point. But from the AMD side, we have a couple of things that we would ask them to take a look at, and they're aware of already, which is, the first is that for a secure loader on an AMD platform, it's initially protected by the DEF protection mechanism. And it's expected that the secure loader will then transition to an IOMMU DMA protection mechanism. Unfortunately, there's not a clean way to make that transition. And so there are some workarounds that we're looking at, and one of them will be what will be implemented initially, because at the end of the day, we need something from AMD and the silicon to assist in making a safe transition between these two protection mechanisms. The next one is the firmware TPM from the PSP firmware TPM. So we've ran into this on a couple of Ryzen platforms where the firmware TPM did not implement the locality for MMIO address spaces. And so for those that are not familiar, when you do a DRTM launch, the locality 4 is what's used by the CPU to signal to the TPM that it has entered the dynamic runtime, that the dynamic launch had occurred. And so that is a state at which the TPM clears the DRTM PCRs and allows it to take the dynamic core root of trust measurement to start up the process. And so without locality 4, you can't get into the higher localities, and you can't do any of your DRTM measurements. And so the SKNet instruction will actually fail on these platforms. And so we'd like to work to get those fixed. So moving on to the commercial firmware area. So we've got this binned in two areas. First is the 3MDev, their Desharo product line. An excellent open source based commercial supported firmware being produced by 3MDev that has a great security story behind it. As you can see here, you can see a lot of the things that they're working on, and in their presentation they'll go into a lot of this in detail and discuss this, and we'll do it justice in terms of explaining what they're accomplishing here. Which brings us to UEFI providers. So there's a few things that we would like to see happen in this space. The first being a proposal made by 3MDev to core boot, but we would also like to work with the UEFI manufacturers and the UEFI community to standardize on a DRTM ACPI table. And the reason we need this DRTM ACPI table is because we'd like to standardize on the information that the preamble requires for setting up for a launch, as well as providing information to the post-launch environment on where it can locate certain items from the launch. So as I said, 3MDev has made a proposal, done a proposal to the core boot community. We'd also like to work with UEFI and get this standardized and have UEFI adopt this table. The other one, which I think is already in progress, which is better or standardized on early configuration of the IOMMU for DMA protection by firmware. This really strengthens the SRTM story, and we would really like to see that in place. The next aspect is SMM containerization. As you can see, these two have a yellow shade into them, so they have hard to fill dependencies. The first one being for Intel, that's the adoption of an STM. So for Intel devices, we'd like to see an STM adopted. For AMD, this one's a bit interesting. So AMD has a capability called SMM Supervisor, and it is a SMM container solution targeted for hypervisors. It is by far the best freedom-preserving SMM containerization capability that I have seen for out there so far. It definitely gives the device owner a way to trust that they have SMM properly containered and cannot do a corrupt SMM cannot do any damage to their system. And so with that, that's our biggest ask for UEFI. So moving into the open source firmware, these are more areas that it's still things we need from the silicon providers, more so than things we're going to produce for the open source firmware community. So in these things, specifically to Intel and AMD both, open up your provisioning tools and provisioning process for the equivalencies of BootGuard on Intel and HVB on AMD. We need to get third-party open source firmwares able to use these technologies. They are a huge improvement to the security of SRTM, and we really would want to see open source firmwares being able to use these capabilities. When it comes to to Intel, one of the other things that we would like to see is the opening of the ACMs. Open source the code. And not only open source the code, but start working towards using a reproducible build for the ACMs. What that buys is the fact that if the code is open, the code can be audited, and if the build is reproducible, then a third party can reproduce and prove that that code is the code that is in the binary blob that we're being asked to trust as our core root of trust. So if you think keeping the code closed is giving you some security, it is not. Reverse engineers are really good. They will figure it out if they want to. Keeping the code closed buys you nothing. In terms of people abusing the code, nobody can create a properly signed ACM except for Intel. And so the fact that the possibilities of somebody creating a rogue ACM is highly unlikely unless somebody can break cryptography and fake signatures. And finally, one of the things 3MDev is doing, as we highlighted for core boot, is they're working on this DRTM ACPI table that they're bringing upstream. So that is one of the contributions we're looking to bring. And so before we transition out of hardware space and into the software space, there is an intermediate area here, which is the hardware validation. The idea here is that we would like to produce a trench boot validation test suite. What this would encompass is all the assumptions and expectations we codify in the solutions we send to the open source projects into a test suite, so that that test suite could be provided to silicon manufacturers and device manufacturers and OEMs, that they can run that test suite against a platform and know that if it passes the validation, then it can ship, and all the open source projects out there will be able to function on the hardware. So that is one of the where we want to accomplish in this domain. And so moving on to the software, the first area of software is the system loaders. So in terms of system loaders for UEFI, one of the things 3MDev is looking to do is to add preamble support, DRTM preamble support, to the shims, to the two shim implementations that are out there, or one or both shim implementations. In doing so, when that is merged upstream, the next revision of the shim that's released and signed by Microsoft would result in being able to more or less directly DRTM launch your kernel from UEFI. Now with that, we move on to Grub. Now Grub was the original system loader we started with. It's the one we're still working on, and we will continue to support. Right now, Oracle is working in conjunction with Intel to build support for Intel preamble, and we'll be bringing that upstream soon. And you have 3MDev, who has built the AMD support for Grub. When the Intel support gets merged, the AMD support will be refactored to align with what was done for Intel, and then merged into Grub, and so that way Grub will be able to do your DRTM launch for both Intel and AMD. Another system loader that 3MDev has been supporting recently has been the iPXE system loader. They have an upstream or a AMD support patch set submitted to add the preamble to that. And so then again, we'd be able to DRTM launch from iPXE. And then the last area that we want to cover is the Trench Boot's landing zone. This is one of the few actual things that's written inside of Trench Boot. It's originated from Trench Boot. The name landing zone was a temporary name we gave it, sometimes referred to as simply the LZ. That name was just given to it as a placeholder for the Git repository. Was not meant to be the permanent name, even though it's kind of started to turn into the permanent name. But that is being reassessed, and so that is why we're saying that there might be a new name here. So the LZ is an open source implementation of an AMD secure loader. And as we highlighted in the hardware section, it is inhibited by the issue of making the safe transition from dev to IOMMU. And so this is a task that we have out there where we're tracking the workaround fix that we're going to put in place, as well as when a fix shows up in hardware, we will then add that as well. One final task that's towards the bottom there that I want to highlight is being done by Apratus eventually, and it was actually part of the original TrenchBoot proposal, is the concept of a measured secure boot. And what the measured secure boot is an attempt to address some of the fragile issues with secure boot. So that for those that are not familiar, secure boot starts with a key signature verification moving into a measurement solution if measurement is being used. What measured secure boot does is it reverses that approach, and particularly on BootGuard. BootGuard supports a measured only verification. So what you would be able to do with this, with a measured secure boot, is you would do a measurement of a component, who would then do your verification, and now that helps you deal with certificate key revocation and a lot of these other things that were exposed in Boothole, because now you're relying on starting with a measurement which you can validate off platform at any time, and it's free to change and can be easily changed, versus what you have with a verification process. And so with that kind of wraps up where we're going with system loaders, and now we're going to move into system kernels. So for system kernels, we'll start off with Zen. So Apratus has been contracted to help build a solution called HyperLaunch. HyperLaunch is going to change the way Zen is booted. There's a few reasons why we're doing this change. One of the benefits to TrenchBoot is that once this change goes in, it would enable the TrenchBoot style launch of starting an integrity kernel, which then initiates a security engine, which is what we've done with the Linux implementation. And then with HyperLaunch, we would be able to do that same kind of approach on Zen. And so once HyperLaunch lands, Apratus will then continue to work to add hashing and TPM support to the Zen hypervisor, so then we can then have that TrenchBoot style launch. For Linux, so Linux was the original targeted kernel for a TrenchBoot style launch. And particularly Oracle and Apratus have been working to upstream Intel support for DRTM into Linux. A patch set's been submitted. We've had some reviews. We have comments. We're working through those comments. And hopefully we'll have a revision of the patch set back out and deal with the next set of comments, or hopefully will be merged. Once the Intel support has been merged, Apratus will begin working with 3MDev to take their AMD patches, refactor them to align with the way the Intel approach works, and then work on getting those merged into the kernel. And to help those understand why we're taking this approach, so when it comes to the way DRTM works on Intel and AMD, Intel has a much more structured approach of what has to be done in the preamble, what's expected to be passed to the measured launch environment, and operations the measured launch environment is supposed to take, using Intel's verbiage for that. On AMD has a more open approach to it. So they leave a lot of that factor of that structuring that you need for doing the launch as an implementation for the solution provider. So what that means is that AMD gives us the flexibility that we can basically mimic the Intel's startup approach and structure in AMD, and therefore we would wind up with this same, like as we said in the core part here, this unified, cohesive way of starting the kernel from a DRTM across platforms. across architectures. So once we're done with Linux, the next area is KVM, Linux KVM. So for KVM, the big thing here to talk about is the introduction of SKINIT and SEnter emulation into QEMU. So why would we want this? What this would do, or an enable, would be you could do a physical DRTM into your KVM solution. Your KVM solution with this emulation in QEMU would then be able to provide a virtual DRTM to its guests. That means your guests can do DRTM attestations to network solutions that would like to see that. After that, one of the capabilities that we have in here that's underneath KVM, because that is the use case driving it, but is applicable to general Linux as well, is the KExec preamble support for DRTM relaunch. And what that is that means that your KVM system can initiate a DRTM launch into potentially an upgrade DRTM environment, for example. And that upgrade DRTM environment can then make the appropriate updates, any PCR adjustments, any sealing adjustments, and then itself could then do a DRTM launch back into the upgraded system. That provides you a strong upgrade story that can be attested to, and without incurring the overhead of a physical system reboot. And so that kind of wraps up what we're looking at in the near term for system kernels and the roadmap for system kernels. Which brings us now to Linux distributions. So Apertus and 3MDeb from the very beginning have been using Yocto as a means to build and test the secure launch capabilities for Linux. So in that endeavor, or in that vein, 3MDeb will continue to expand the layer, add platforms, expand the test cases that they have, and then we would work to get those layers merged up into the larger Yocto ecosystem. Then from there, looking at the other distributions here, we've focused on, these are the ones that we are focusing on at this point, which are Debian, Ubuntu, LFEdge, and Red Hat. Obviously, the big three are there because that will lead to largest adoption within the general Linux community. And LFEdge there is our representation for our IoT Linux distributions that we would like to help get adopt these trench boot capabilities that we push into the upstream projects. So as we deliver these capabilities into the upstream projects, we would like these distros to be able to package them and make them available, so that way the end user simply just needs to do a package install with a potential after install helper running to help configure the DRTM or launch integrity solution. So in that vein, we need to be able to work with these distros to get incorporated in their CI, get their packages, get packages built for them, get helpers built for them if needed, and get this all published into their package repositories so it becomes available for end users. And so with that brings an end to the roadmap. And so where does that leave us next? And so what that leaves us is that while we've already had a lot of success and progress to date, there's still a lot of work to be done. And so therefore there's still a lot of ways for people to be able to contribute to the project. You don't need to just be able to write security code for integrity solutions. We need system administrators to help us build up system integration tools. We need documentation. We can also use configurations, and if you work with a distribution, we need help with it getting incorporated into the distributions. There's lots of ways that people can assist with the project. You can help, take um, beta builds of the solutions and help test them out. There's, again, lots of ways to help. And so, in that vein, come join us. You can find us on the Trench Boot channel on the open source firmware Slack. We have a mailing list. We have there's our website, and you can always just talk with us during the open discussion period during later today. And so, with that, I would be glad to take any questions for whatever time we have left. All right. Are there any questions?
Daniel, quick question.
Sure.
So you had talked about all these different roadmaps, but how about, are you thinking anything along the lines of remote attestation?
So I am, yes. We didn't put anything on the roadmap. That is definitely an area where we can. So one of the things that didn't get put on the roadmap that I realized after I published the video was some of the work that Oracle and myself have been doing on URoot, right? And so that was the usage of URoot was supposed to be the exemplar of what you could do for a security engine. And so, yes, we would want to be able to introduce the ability to do remote attestation into URoot, so the exemplar would be out there. So, yes, that was slightly missing from the roadmap. And so that was not intentionally left off for those that were curious.
Okay, thanks.
Mm-hmm. Yeah. Hey, Daniel, is there any documentation on how trust is extended from a physical DRTM implementation into a virtual DRTM implementation for like KVM, like you were mentioning?
In terms of like writing the security story behind it, no, I have not written a security story behind it. If you'd like to collaborate on one, I would be glad to.
I'd be happy to. Yep.
Yeah. So, but yes, we need to be able to have a good story behind that, right? So people can understand what they're trusting if they're getting a virtual DRTM.
Absolutely. Yep.
Yep.
So in terms of the support in the QEMU, you mentioned in the roadmap, so have you seen significant interest in the folks for that feature?
I've mentioned I have mentioned it to people before. I know some people are interested in. It's intriguing to them. I don't know in terms of adoption how much interest in adoption is out there. I would think that with the way security is moving in general, and solution providers are more and more looking for you to provide attestations, I would expect that this capability could be found to be very useful for a variety of use cases. So that if, for instance, if Brian and I were to do a write-up of it, part of that could be discussing the possible use cases and to help evangelize the capability for people to consider.
Now, the reason I'm asking that is now we are seeing all these technologies like SCV and TDX and all those things coming out, and how would that intersect with the capabilities that you're planning for the QEMU?
So, yeah, good question. I have not looked. I guess a gap for me is I have not looked at how the emulation is working on those platforms, right? So, I mean, at some point, I would expect that when you're using these things, that you have to fall back into your instruction emulation. So, that would still be there. How that security story works, it would again be something that when if we were to do a write-up, we would have to walk through.
Yeah, I think you would have to weave a nice story around the trusted execution environments versus the emulation and the KVM support that you're talking with Brian. And
yes,
interested to see how the whole thing fits as a consistent story.
Yeah. Well, and then on top of it, right, doesn't TDX have an attestation story behind it as well?
Yes, it does. Yeah.
Yeah. And so yeah.
And that is the reason why I was asking you about the attestation earlier, was because we will pretty soon will have to start looking at how we are going to be supporting TDX and all those things. And I want to see how this fits in with Trenchboot.
Right. So, I guess the question is how do you want to gain? What do you want to gain from using Trenchboot in conjunction with these technologies? I mean, at a minimum, you're just being able to have guarantees about the hypervisor that you started. That's good from the cloud provider's perspective. You want to know you have a healthy hypervisor, even though you also are providing guarantees with TDX for your customer base. So you have to reflect on who's going to be the end consumer of the result of the measurements that come out of the DRTM.
So going back to the question as posed, there isn't actually a direct correlation between the emulation in QEMU and TDX or SEV SMP directly. Both TDX and SEV are designed to remove the hypervisor and ancillary systems from the trust. So in both cases, with AMD and Intel's solution for fully encrypted VMs, you are talking to either the PSP directly or to, I think, part of the management engine in the Intel case. And you can already attest to the state of the system there. The point there is that it now moves the main hypervisor out of the trust situation. You still want to be able to try and verify that the hypervisor booted up well, but you're never going to be in a position where the DRTM story inside the encrypted VM is dependent on the DRTM used to boot the host, because the point of these technologies is to separate those two areas.
Okay, thank you, Andrew. So yeah, at the end, we want to bring DRTM technology to everything we can so it can be used in the use cases that it makes sense. So as Andy pointed out, it might not make sense for a DRTM for a guest in this situation because you have other hardware-based mechanisms that you could take leverage that might put you in a better position. But then if you're on a platform that has neither of these technologies, or you don't want to deploy these technologies, it gives you an avenue to help give you a security story through to your guest.
Yeah, so Daniel, that was the point I was trying to get to, was like, would the growth of like TDX and SCV sort of like diminish the need for trying to do something in the QEMU emulation? Because we were also thinking about that for a while, and then it occurred to me that like, if we are trying to go into the TDX and SCV route, then is it worth to invest effort in developing that? That was the question that I'm trying to answer at this point.
Oh, yes, there are plenty of use cases that wouldn't necessarily want to use TDX or SEV. You take a look at a number of the open source projects that do hypervisor-based security for a laptop or a general client device. And there you're never in the position of distrusting the hypervisor, but you need the VMs to cooperate whilst also having strict bounds around them. So in cases like that, you wouldn't want you wouldn't want to be using fully encrypted VMs, partly for the performance overhead and partly because it actually gets in the way of making a nice system in the end. So there are definitely use cases where you would want to tie your VM integrity to your hypervisor integrity.
Okay.
And in reality, something like TDX is aimed at a sort of a consumer, right, of like cloud services, where the consumer doesn't necessarily want to trust the cloud provider. However, the operator, the cloud operator, still wants to have trust in its systems, right? And TDX isn't necessarily going to provide that for you, right? So they're sort of, I think this is the point that maybe Andrew was kind of making initially. They're sort of different tools for different purposes.
Yep. Okay. Any other questions?
Yeah, I have a question with regards to the plans with regards to the shim development. As I saw, we are going to implement something similar, which is currently implemented in the graph, to start the RTM directly from the shim. Could you explain why you want to do that, and why you need that this functionality?
So Piotr and 3M Dev are the ones that were looking at doing this. So if one of them would like to answer that, I mean, I can give you some reasons why I would look at it, but.
Yeah, I'm not sure I'm getting this point. Michał, can you help me, or Christian? I'm just wondering if that's the correct point, that we're trying to do something directly from shim.
I'm not exactly with shim, but I thought we were planning to implement a PE header for the LZ binary, at least, to have it signed, for example, for secure boot purposes, and only authorize some authentic LZ binaries to be launched with TrenchBoot.
Yes, so our position is a little bit different because we typically control the certificates and all the secure boot, all the UEFI stuff we produce in the firmware of the platforms that we help build, and that's why kind of running directly, kicking LZ directly from UEFI is something that may help us. Also, iPXE could benefit from that because we can leverage UEFI boot using iPXE through SINET LZ binary. So that's kind of ideas behind that. It's not related to shim or to kind of way of handling secure boot plus binaries on typically available UEFI platforms.
So are you going to start directly from shim, LZ, and then the graph, or directly the Linux kernel or something like that?
I believe like our thoughts were more around iPXE.
Okay.
So UEFI shell, iPXE, and then we want to load SINET. So we want to have still secure boot enabled, and then we want to kick LZ.
Okay, this way. One thing is just, if you are going to change anything in the shim, you have to be very careful with that. And please contact me first before you do that, because in general the shim code should be as minimal as possible. So as far as I can tell, shim maintainers are very careful with regards to taking any code in the shim. Problem is that because this is security component, and it has to have less bugs as possible. This is the problem. So I think that my understanding is that if you want to start to introduce some code into the shim, please start discussing this with developers, because I can expect that in some cases they can be very reluctant to change some changes into the shim. I can help with that because to some extent I know the expectations, but I would like to make you aware that you have to be very careful with designing anything around the shim, because it has to be as small as possible.
Yeah, so I don't think, Daniel, we're planning doing any changes in shim. Maybe the more related stuff here, and maybe not everyone on this call knows that there is a working group trying to do secure boot for Zen, and that group may think something about shim related. So this is helpful information. But maybe let's get back to the trend stuff.
Okay.
Yeah.
So maybe
go ahead.
Yeah, I'm sorry.
Go ahead, Piotr.
Yeah. So at some point I asked you this question more in private channel, but I'm wondering how you envision sponsoring of the project in long run. We know that there are some corporations involved. There are some smaller organizations. There are some people in community asking, and maybe they could deliver something, contribute something. How you envision this work go forward? We have like beefy roadmap, but who will sponsor that? Who will? How you think this will be sponsored, and how those features will move forward?
So I guess it's a loaded question there. So, I mean, obviously we have, for instance, we have Oracle, who is, contributing and working with this. Well, they were here from the very beginning, right? Because they want to incorporate that into their own product. So they are sponsoring developers to work on the project. So depending on how the corporate sponsor wants to become active in this, that they have some, clearly if they're approaching us, they have some use case or end goal for this, for something they want out of this. And so it just becomes a question of how they want to be able to contribute. Do they want to sponsor one of the existing contributors? That happens all the time. Or do they want to provide their own resources to help start working with the project? And then, that would just be, them introducing who they want to assist, and we would welcome them to the community and work with them on the contributions they can make. So I don't think there's a one-size-fits-all answer. I think it's going to be, if people want to get involved, especially corporations, they're more than welcome to. Just approach us. They can email me. They can come to the. There's a handful of ways. We've got the Slack channel. We've got the mailing list. There's a variety of ways they can approach us. So.
Can I make a comment on that?
Sure.
If you look at that roadmap spreadsheet, agree with that, or want to?
Yeah, no. That is a very good way to state it. All right. We have a couple more minutes before we start the next video. The one thing that was brought to my attention since I published this video, so when I was covering the SMM topic in the hardware space of the roadmap, I collided two terms. So the general area is SMM protection and isolation, and there's actually two capabilities from AMD. There's the SMM supervisor, which is the upcoming capability for Secure Core, and then there's the SMM containerization, which has been present for some time within their specs. So in particular, the freedom preserving capability is the SMM containerization that they have. So, and with that, I'm going to transition into the next video.
Hello everyone, and welcome to TrenchBoot Developer Forum 2021. Today I will talk about 3MDEP contribution to TrenchBoot project. The presentation was made by Michał Żykowski and me. So who am I? I'm Piotr Król, 3MDEP founder. I'm open source software contributor, conference speaker, organizer. I'm also former Intel BIOS software engineer. I'm 12 years in business, 6 years contributing to open source firmware, and I'm also have C-level position in some other companies, which logos you see here on this slide. Who we are, what's 3MDEP about? 3MDEP is a core boot licensed service provider since 2016, so we're doing core boot development, open source firmware development. We are in core boot project leadership. We also are UEFI adopters since 2018. We are also consultants of official consultants of Linux Foundation FWPD LVFS project, as well as Yocto participants and embedded Linux experts. We evangelizing usage of open source firmware, and we are highly enthusiastic about it. So first of all, I would like to thank a bunch of people without whom the contribution that I will present here would not be possible. So first of all, Daniel Smith for creating TrenchBoot project, Rich for motivating every one of us to move things forward, Andrew for highly technical discussions and reviews, Daniel Kipper for Grab consulting and discussing about Grab implementation, Ross for LZ and kernel development, and Christopher for support in Yocto Meta TrenchBoot and other area related to Yocto project. Of course, it would not be possible without 3MDEP team support. First of all, Christian, who made a lot of contribution, as well as Michał, Norbert, who did Chara related stuff and a lot of Yocto, Maciej for guiding Yocto related development and contribution, as well as whole test automation team, which added the hardware validation lab and be able to verify all the newest version of the code that we developed. And finally, NLNet Foundation for sponsoring a bunch of this project. So how the 3MDEP contribution stack look like? First of all, let's start with hardware on the bottom. So we did mostly development on AMD processors, from old one to some newer one. Our platforms span from PC engines through Asus, Supermicro, and ASRock. We used as a firmware both open source firmware implementation as well closed source based on UEFI. Then we, as a bootloaders and payloads, we used iPXE and Grab. And then on the kernel and hypervisor level, we used Linux kernel, Zen hypervisor, and Landing Zone, which we can consider secure loader and secure kernel related project. And that's why Landing Zone that's the only place where we have TrenchBoot logo, but to be honest, TrenchBoot contribution is spread around all this project which you see on this slide. Finally, on the operating system level, we used NixOS, which has very interesting capabilities. Please take a look at this operating system since it is very, very, very interesting. Yocto project, which gives us very flexible way to compile kernels and all the related components for Trenchboot, for validating Trenchboot, and then Debian for building packages which are easily to install and easily to test. Finally, in user space, we typically use two use cases for RTMs. Either it is remote attestation, either this is unsealing of the secret. So Chara is a Fraunhofer reference implementation or proof of concept implementation of RAT's IATF specification. So this is related to remote attestation. Then SafeBoot is a Trammell Hudson project which simplifies disk sealing and unsealing process, and we added the DRTM PCR's support for this project. And then we have also Robot Framework, which is also user space, but it's not related exactly to Trenchboot on the system, but more like a validation system. This is like a framework for performing automated validation in our labs. So speaking about hardware validation and our lab, this is diagram of the 3MDEP remote testing environment lab. So on the left side you can see that there may be various end users. Those end users either can get through some gateway, either through VPN, either through REST API, and can trigger tests written in Robot Framework. Those tests discussing with something called remote testing environment, RTE, which you can see on the middle of the screen. This RTE is an open source hardware project. All the schematics are public on GitHub, so you can either buy this from us or you can build yourself. And this is used for flashing SPI, for power cycling the platform, and like hooking into the platform and managing all the states of it, so it can be done completely remotely and completely automatically. Then we have like a bunch of platforms. Of course, I didn't put everything here, but we have like 2 racks of platforms that we're testing with RTE. Some of them are related to Trenchboot. After these tests are made, there are some test results which are dropped into the spreadsheets for reporting. Right now we're even working on Dasharo transparent validation system, which is a portal which will give the ability to better look into the test reports. In case of firmware contribution, first of all, we did the ACPI DRTM resource table implementation in Coreboot. So this is Trusted Computing Group compliant ACPI table, which inform us about where are the DRTM resources located. This is needed for next points for DRTM event log. So event log can be used for either debugging, either remote attestation, simplification of remote attestation, since it contains all the information about what hash was extended into the PCRs, and then also you can add someone who's extending that can add some note which explains what was extended. Then we did AMD IOMMU support for some platforms in Coreboot. This is mostly for PC Engine's APU2 and ASUS KGP D16. And then we also started some Intel stuff, but it's going very slow. There is not much resources related to that, but we're slowly progressing with Intel Ivy Bridge BIOS ACM support in Coreboot. The ASRock and Supermicro platforms were with the proprietary UEFI firmware, so we used stock firmware for validating Trenchboot. And there was, of course, no contribution to closed source firmware. What we did on the bootloaders and payloads level, first of all, in iPXE, we added support for starting Trenchboot landing zone. So right now, we are able to boot Linux kernel. Of course, it requires Trenchboot patches, as well as Zen through Multiboot 2 support. So all the patches are on GitHub, and you can see how this is done. There are some small limitations to that, like to most things in Trenchboot, but that was added and tested. For grep, we mostly did DRTM event log. So DRTM event log will be repeated here many times because it have to be supported across whole stack. So as I said, it allows remote attestation and debugging scenarios. And we did AMD SKIN core implementation in grep 2. So there are a couple patches that are still hanging on grep dev mailing list and awaiting for review. In case of kernels and hypervisors, For Linux, this was mostly done by ROS, but we did some improvements. This is not yet published upstream, but there is support in 5.8 Linux kernel for AMD Secure Launch. In Zen, we added minimal code to boot Zen through SKInit and LZ, and this was already merged by Andrew upstream, of course, thanks to his support. In case of landing zone, probably the most work we did is in landing zone. So first of all, we ported the SHA-256 implementation from Linux kernel to landing zone. Then we did variable separation, so we can keep hashes of the values independent of the memory layout. Otherwise, we will measure something that may change depending on the memory layout, and this defeats the purpose of the stable measurement. Basic support for forward sealing, so we added some basic scripts so we can then predict the PCR values on the next run, and that helps, of course, with forward sealing, which is one of the use case of the sealing and unsealing is one of the use case of the early launch of the RTM. Then there are a bunch of patches awaiting review, like multi-boot 2 support. Of course, this was tested. It works with Zen. But still the patches are not merged into the LZ. There is, of course, the RTM event log support, which is also not merged. And then there was some early IOMMU support, but this is very basic, and this is very basic protection against DMA attacks, but cannot be merged right now because of the bug in DEV mechanism of AMD. What kind of things are still to do? In case of issues, we have 5 open issues. Those are mostly related to open pull requests, but not everything is public. There are some known issues which were not yet reported. I believe some cleanup is required. Then we have problem with IOMMU DMA protection. This cannot be implemented in secure way in current version of the processors or microcode. Maybe it depends how this can be fixed. So due to hardware bug in DEV mechanism, which blocks IOMMU from reading the configuration created in SLB, we cannot implement that in correct way. So this awaits some mitigation either from AMD, or maybe someone will figure out how to work around that. Then we need configurable builds, because LZ is just 64K, and definitely there will be builds dedicated to some types, or like some groups of machines or some groups of platforms, and then of course this needs some configuration. So extensibility of the build process of LZ is needed. Then refactoring of LZ binary layout is also required after this long development, and then continuous integration and continuous deployment infrastructure improvements. Despite there is some work already made, we still need some improvements to make it work all the time, to be able to validate patches that incoming and merge requests that incoming to GitHub repository. Finally, it would be great to have PE header, because this will enable UEFI secure boot purposes, and this would help in joining the secure boot and DRTM words on typical machines, UEFI based machines. In case of operating systems, for NixOS we did support for trench boot in Nix packages. So if someone wants to test on NixOS trench boot the kernel and all the required components like grep, LZ, and all necessary things for Nix, that's possible. We documented that on our blog post. If you are interested, please go there. There is also pre-configured Nix repo to host the components, and then there is also CI that can build these components, and then we can check like what kind, if build process still works, and as well, all the CI related stuff is there. Then we have Yocto. We created meta trench boot layer. We still don't know what would be the future of that. Maybe it would be merged to some other layer, maybe to some, I don't know, meta security, or that's the discussion that we can make after the presentation. There are WIC plugins for partitioning, so legacy and UEFI partitioning is already supported. And we have also CI for Meta Trench Boot, so we can build the images and check those in our hardware validation lab. In case of Debian, we building all the required packages to run Trench Boot, to execute DRTM through LZ. And yeah, we have package for landing zone, for grub, for Linux kernel, and this already works. We have also CI awaiting for that purposes. In case of user space scenarios, there are two major user space scenarios: unsealing and attestation, as I said. So first, for unsealing, we used SafeBoot. We added some support. We found some small bugs that had to be fixed to support sealing secret to values of PCR 17 and PCR 18. There is also possibility to use SafeBoot for attestation, but there is no server associated with that. There is like just simple TPM attest quote, and you got just getting target zip that you can send to some remote location for attestation. But still, this is supported. But main use case of SafeBoot and what was implemented is sealing secret and unsealing. And using that secret for encryption and decryption of the hard disk. Then Norbert did the Fraunhofer-Chara related implementation for remote attestation. Right now this is very, very basic, so just verification of TPM quote signature is done. This signature is this TPM quote signature was generated by the Chara attester, so this is completely like unattended. Just attester kicks the communication with the remote server, and all works according to Chara and according to IETF RATS specification. Okay, to sum up, we worked like around 2,400 in engineering hours. Some of that, or most of that, done non-profit. And this took us like around 2 years, so maybe this is not much, like 100 hours a month, but still when operating without funding, this I believe was a quite big contribution from so small organization like 3MDEP. We were able to create some contribution to 11 projects, and those either received patches and those were merged or awaiting review. There were 10 conferences presentation on which we promoted Trench Boot. You can find those on our website in events section. There were 16 blog posts published, which you can easily find on our blog under tag Trench Boot. And of course, if you're looking for experts in area of firmware, Yocto, NixOS, Debian, Chara, whatever software stack we mentioned here, plus DRTM or SCRTM, feel free to contact us. You can do that through either website, through contact subsection, or directly through email, or whatever channel you want. If you find me on social media or Michał, that's completely fine. Finally, I would like to give you a short pitch about Dasharo. So Dasharo is a kind of set of productized service, open core and SaaS products which we were able to build over the last 6 years to create scalable, modular, and easy to combine open source firmware, UEFI, and firmware solutions. So both open and closed solutions, or kind of mixed solution. It offers components that are not needed to develop and maintain. So those components are needed to maintain high quality modular firmware. So we have validation system, we have like build systems, we have like all the signing procedures and releasing procedures. We're doing that for some projects monthly for more than 4 years. So that's already tested and verified ecosystem. And how this is related to Trench Boot. So the ultimate goal of 3MDEP is to leverage all Trench Boot related features through the Dasharo ecosystem. So what kind of features you may see in future from us? So first of all, the Dasharo provisioning, deployment, and recovery server. So how we envision that? We envision that as some kind of payload, some DLME which is kicked over network and gives ability to either provision the platform for some needs, either deploy some operating system or some configuration, or recover the system from the failure state. If we can kick that, let's say, before the operating system start. The same thing can be done for debugging server. So in that way, we are sure that we running only debugging software which is approved by the platform owner or by some vendor who wants to protect that. As well, attestation server, of course, this most probably based on Fraunhofer Chara. Then definitely we would like to look into ability of implementing secure firmware update through FWPD LVFS in DLME. So we are already FWPD official consultants, and we would be glad to leverage that position to kick the FWPD inside the LME, and then in that secure space, like measured environment, do the update process. There is also a project about offline attestation, but I cannot talk much about that yet. You will probably get more information soon. And finally, through some requests from customers, application-specific solutions based on Linux and BSD environments. So one would be disk encryption decryption based on sealing-unsealing process using DRTM PCRs, and system updates like Yocto SWPD system updates or some BSD system updates driven which getting through the DRTM launch process. Okay, so finally, how to join us? The fastest way is just register to Slack osfw.dev. On this Slack, this is open source firmware Slack. There is a channel called Trenchboot. Feel free to join there and talk with us about your opinion about Trenchboot, about use cases for Trenchboot, and whatever you want about Trenchboot, you can ask there. There is mailing list, of course. It's mostly right now very technical, like all the patches are going there. And finally, there is a website, trenchboot.org. Still not much there, like mostly links to the GitHub, but this is good entry point for learning more about Trenchboot. So thank you very much, and feel free to ask questions either below the video or during the talk after this presentation. Thank you very much.
All right, with that, does anybody have questions for Piotr and his team? Can you hear me?
Yes, we hear you.
No, we can't hear you, Daniel.
All right. I would think there would be at least some questions for Piotr. If not, is there oh, go ahead.
I'm very interested how LZ will be used to directly start the Linux kernel, but I'm not sure we have time to discuss this here. Maybe we should discuss this on the Slack channel. This is very interesting for me.
Yeah, right, because that means the LZ has to become aware of the Linux boot protocol.
Not only, I think, but you have also passed the information about initRD if it is not embedded in the Linux kernel, and also some arguments. So this is interesting. Anyway, I would like to be involved in this discussion.
Okay. So I guess outside of that, Piotr, do you want to talk about Dasharo any?
Yeah, if anyone have questions, like right now, so what I can say, so Dasharo is a set of services that we put together to continuously deliver the firmware, validate the firmware, and then rapidly develop the firmware for our customers. The problems. So recently I made this joke after Eugene. So what we need for Trench Boot. So for Trench Boot we need Trench Boot friendly BIOS because for example for Intel we have this situation when we have to include ACM BIOS or BIOS ACM, and then of course everything have to be correctly glued, and then we can kick bootloader which can load the SCNIT ACM, and then we can move forward with early launch. For AMD, this is different story, but anyway, in both scenarios, so for Intel and for AMD, we have to correctly prepare everything, have good firmware that can prepare everything to kick Trench Boot in a safe manner, because we depend on DMA security, we depend on correctly set up SMM. So if we have these dependencies, either we have to have some SCRTM, so static code root of trust for measurement, which will protect our BIOS. Either we have open source BIOS which we can audit, but of course even in that situation it's good to have some static code root of trust because of the DMA and SMM problems. So that's why I think Dasharo is important for Trench Boot, or some ecosystem that can build firmware which brings the environment in a way that the RTM can be launched in safe manner with correct preconditions. So I believe, like, of course, we would like to get to the world where firmware would not be needed, or firmware impact would be limited on the RTM, but it seems that we are still far from that point. And that's why I think 3MDEP contribution from the firmware realm can be helpful for various commercial partners and even for community. So that's why we're doing this for Coreboot. Maybe like I saw questions from Konrad about EDK2, and definitely we thought about bringing that to UEFI forum. We are UEFI adopters, so we have some capabilities of explaining to UEFI forum the problems related, and that it would be great to have this introduce it in correct way. So support for ACPI DRT table, the RTM table, as well as support for the RTM event log. But yeah, still this means some resources which 3MDEP right now don't have. But maybe in future, if there will be customers needed this kind of capability, we would be glad to support that.
Okay.
So yeah, and all these pieces, no matter if this is Coreboot, open source BIOS, or this is Linux boot, or this is UEFI, we are interested in all work related to low-level firmware development and to creating correct environment for the RTM. So yeah, so that's Trench Boot about, like, to
all right,
create good base ground.
Okay, thank you.
There is Daniel Smith.
Yes.
I have a quick high-level answer to Daniel Keeper's previous problems.
Sure.
That I dredged up from the early days of us discussing the landing zone and how it would fit into Trench Boot. And I believe the answer is, unless it's changed, is that most of the kernel setup would be done by the bootloader that is kernel setup aware, and then the landing zone would function analogously to the ACM and do the sorts of tasks the ACM would do, and then vector to the kernel in a way similar to what the Intel ACM does.
Okay.
Yeah.
Thank you, Ross. Makes sense.
Yes, that's thank you for reminding me of that. So there was a question on the Slack channel real quick, and Piotr already answered it, so I'd like to give him a chance to answer it live as well. So somebody asked what AMD Dev was.
Yeah, this is Jean-Philippe, yeah.
Yes. Yeah, so I wanted to give you a chance.
Dev is the device exclusion vector. It was a technology brought in at the same time as original virtual machine support and DRTM support. It's kind of a precursor to the IOMMU. It was a very simple 1 bit per page of access or no access, and it's controlled. It's mediated by the memory controller or the memory controllers in a bigger system. So it's a logical precursor to the IOMMU, and in more modern systems, most of dev has been dropped entirely. The 1 bit that remains is the secure launch capability, which is a single 64K region that has DMA protection via the same mechanism.
All right, thank you, Andy. All right, and with that, we'll transition to the next talk.
Hello, everyone. My name is Daniel Kipper. Today, Rose, Patrick, and Brian and I am going to present secure launch with TrenchBoot developments. Next slide, please. Here's our agenda. At the beginning, we would like to introduce some definitions and terms. Later, we will move on to the major pieces of the TrenchBoot framework. I mean grub2, Linux kernel, uroot, and MLE management engine. So let's discuss two most important terms in the TrenchBoot project. So TrenchBoot is a framework that allows individuals and projects to build security engines to perform launch integrity actions for their systems. So the TrenchBoot is a term which describes a framework. Secure Launch is an implementation of TrenchBoot framework. And here in this presentation, we'll be focusing on Intel TXT implementation of TrenchBoot framework. So as I said, we will be discussing various components of this implementation. And at the beginning, I would like to move on to grub2. Next slide, please. So why we decided to use the grub in the TrenchBoot project? Now, first of all, the grub is the most common bootloader in current deployments. So this means that you can use easily in various operating systems, including Linux operating systems, the grub to start the TrenchBoot framework. So that is why we decided to use it. Also, the grub works on x86, legacy BIOS, and UEFI platforms. This is another good thing about the grub. And also, the grub can be built for many different architectures, including, for example, ARM. So this means that potentially we can have an implementation of a secure launch, for example, for ARM, which shares the common code between different architectures. Of course, some specific stuff for a given architecture has to be implemented for this architecture, but I hope that there will be a lot of code which can be shared between our architectures. Also, another property of the grub is that it can be a part of a payload of a core boot, so it simply can run from embedded systems or run without BIOS or UEFI. So you can speed up initialization of the platform using just a grub to load the rest of components of TrenchBoot framework. Next slide, please. So how it works? So in general, the grub is loaded directly by the platform or from UEFI or from the BIOS. and then you have to execute a few steps to pass control to other different stages. So initially we have a command which is called slunch, and this command slunch checks the platform for required features and does initial setup of the platform. After that, we have to load sinit ACM into the memory. It can be done automatically. This is the goal for the grab. So it will match the sinit ACM with a given platform. But we also want to have an option to load the sinit ACM using special command called slunch module. We are going to leave this option to enable the debugging, or for example, if you need to use specific ACM, which cannot be detected easily by the grab, it can be used on the specific platform. After that, we have to load into the memory the MLE kernel. And MLE kernel has to be loaded by Linux command, simple, in this case, a Linux command. This command currently loads the Linux kernel, which is integrated with init ramfs, which is implemented in uroot. But of course, in the future, potentially you can use the separate kernel with a separate MLE init ramfs, which can be implemented in different way. After that, we have to do platform initialization, further platform initialization, including PMRs, anti-errors, TPM, and also the CPU. If everything goes okay, then we switch to the relocator. The relocator is a piece of code in the grab which places all binary blobs which were loaded in earlier stages in the final resting place in the memory. So after the locator does this work, we call the instruction called senter on Intel TXT platform, which transfers the control from the grab to the sinit ACM, which does further platform initialization, and after that executes MLE. Next slide, please. So, as I said, currently we are focusing on Intel TXT implementation, but we are thinking also on similar DRTM implementation for AMD platform, which is called SKINIT. We think that it is possible to share as much as possible code for these both implementations. Same also applies to the legacy BIOS and UEFI secure launch code. We think that this code can be also shared between those implementations to some extent, of course. As I said earlier, platform initialization should be automated as much as possible. What does it mean? So the grab should detect the type of platform and initialize it properly for secure launch. And additionally, the grab should match ACM or secure launch files in case of AMD SKINIT with the platform and load them automatically. As I said earlier, we are going to still leave an option to load these files manually in some cases, for example, like the binding, but mostly the grab should load these files automatically. The grab should provide a minimal secure launch diagnostic mechanism. Initial RFC patches which were posted on the grab devel provide such a mechanism. It is a simple command which displays the status of the platform on the screen. It, for example, gives information about TXT registers, etc., etc. This eases debugging of the issues of TrenchBoot project without a requirement to boot the platform twice to get information about potential errors during Trench boot initialization. So if you encounter some problems during MLE boot, you just boot your platform once again and just execute a grub. You don't need to go to the fully blown operating system to execute special binaries to get this information from the platform. So this is huge advantage of having this functionality in the grub. We are also working on introducing firmware and bootloader specification. This will be quite generic, I think, specification, which will be used to pass logs from earlier machine bootsteps to running operating system kernel or user space. The spec is under still work in progress. But we have in an initial implementation of such functionality for one of the first versions of the spec, and this gives this pass information from the grub directly to the Linux kernel and further to various tools, which can extract information about various bootsteps which were done in the grub from the MLE kernel or later from the OS. So we are going to finally implement this functionality in the grub. Of course, there are also some components which should be implemented in the kernel and fully integrated to have this functionality working later. So next slide, please. So let's take a look what is happening right now in grub upstreaming. Currently, the work is done mostly by Intel and Oracle, and we are focusing, as I said earlier, on Intel TXT implementation. RFC patches were posted by Oracle at the beginning of May 2020. Right now, Intel is continuing development of these RFC patches, and we expect that next version of patches will be posted after grub 2.06 series. In parallel, FreeMDEP folks are working on AMD SK implementation. As I said, we are going to implement both functionalities in such a way that some common parts share almost the same code. So this is our goal. So that is why the first implementation of these patches, which were posted on GrubDev, were based on Intel TXT patches. And we are going to discuss later how we should cooperate to speed up this development, and I hope that by the end of this year, all these patches will be integrated in the grub. So right now, we would like to move on to Linux kernel implementation of secure launch. So over to you, Ross. Thank you.
Thank you, Daniel. My name is Ross Phillipson. I did most of the work on the secure launch kernel part of this. So as Daniel mentioned, we're currently focused on Intel and TXT. So the Linux kernel we're talking about is what is called the MLE, the Measured Launch Environment, and this is what is entered after the SINET ACM runs. So this kernel needs to have a special entry point because of the state that the bootstrap processor is left in post-launch. So the kernel has to handle all the setup in that post-launch environment, and it also needs to handle enabling the application processors, or APs, because they're also left in a very specific state by the running of the SINET ACM. In addition to that, the secure launch kernel is responsible for taking measurements of anything that's going to be used by the MLE. There's more on this later on exactly what is measured, but basically the measurements are SHA-256 hashes, which are extended into the PCRs at the TPM in the very early kernel startup. The kernel also provides a security FS interface to allow
to allow the uroot user mode components to access the TPM event log and TXT registers, the public registers. And then secure launch has to also hook KExec and the shutdown and reboot paths to be able to issue the sexit leaf function for TXT to actually exit SMX mode properly before it either launches the next kernel or it shuts itself down or reboots. Our current kernel is built using a minimal configuration to reduce as much as we can of components and drivers in the trusted computing base to reduce the attack surface of the MLE. Next slide. So this is an overall picture of the flow of the actual boot. As you can see on the very left top, after grub runs, it executes with the sinit leaf function for TXT. That causes the ACM to execute. The ACM establishes the DRTM and launches the MLE, the measured launch environment, which is the secure launch kernel. And as I said before, the MLE entry point, the MLE has to have a special entry point because the processor is left in a very specific state. So the early code, the early 32-bit entry point code for the MLE has to prepare the environment and restore all the things that need to be restored, like the MTRR state. And finally, it just jumps off into the standard setup, a startup 32 that's found in head64.s. And from there, and this first orange block at the top is, as is noted, is the compressed kernel. So this is very early in the boot process. So it jumps off to startup 32, which is unmodified compressed kernel code. The compressed kernel continues to run a little later on after it switches to 64-bit mode. That's when some validation is done and the measurements that I discussed earlier are taken and sent to the TPM. After that phase is done, it basically returns and there you have a standard kernel decompression and launch from the compressed kernel. And of course, the compressed kernel decompresses the mainline kernel in place, and that's the second orange. Rectangle in the middle. As you can see, there is no custom code in there of ours that is needed. It basically does a standard kernel startup. There are a few spots from the kernel startup that it calls out to our code, to the secure launch code. Early on in the setup code, it calls the secure launch late validation and setup. This just validates various platform configuration state, and it finishes setting up things to run to run the kernel as the MLE. And then the next stop in the early setup code is for some custom secure launch AP startup code to run, because the APs cannot be started in the standard way by, for example, by asserting init and sending startup IPAs. So this code is so the APs are actually are idling, waiting for this code to start them up with IPIs from the Bootstrap processor, because they can't be started the normal way. And so that code resides, that small chunk of code to start to do the custom start of the APs it resides within the SMP boot code. And then the final stop before the kernel's fully up and running is bringing the security FS interface online, which again, we use that to expose the TPM event log, and we use it to expose the public TXT registers. And then the kernel continues to boot up unmodified, does all of the rest of its setup, loads. In our case, we have an embedded init RAMFS, which contains the rootfs and the uroot code, and the kernel just starts that in the normal way by running the init routine for uroot, and then uroot proceeds to the uroot code proceeds to run the the security framework and do the security tasks that the policy specifies. There's more on that coming in the next section. And then finally, the final stages for the uroot for the security framework to issue the S-exit before it does a K-exec of the follow-on kernel. So next slide. So this just kind of covers some of the measurements that are done. The SNIT ACM itself extends various. So one thing to note is that only when only when a measured launch is in progress are certain localities in the TPM available, and these localities are contain the piece. The ones of interest to us are like our PCRs 17 through 22. And the ACM extends various things about the platform and firmware into PCR 17 and 18. Most importantly, the ACM extends the measurement of the MLE kernel itself into PCR 17 before actually executing it. And then, as I noted earlier, the very early post-launch code also extends various values into PCR 17 and 18. These values include the command line, boot parameters, any setup data structures, the EFI memory map information, and a piece of the TXT heap, which is the shared area between TXT and MLE. This area is also extended into PCR 18. If there's an external init RAMFS, which in our case there isn't, it would be extended into PCR 17. There are settings to allow you to alternatively use PCR 20 instead of 17 and PCR 19 instead of 18 to allow more flexibility in the way you want to use the PCRs. So you could segregate the ACM measurements from the post-launch MLE measurements. And there's also a feature, we have a feature that you can use at build time, you can configure it to bypass the kernel command line, basically kernel command line parsing and interpretation. And it would also not be measured since it's not even being processed. Next slide. So the upstream effort, we had sent out a previous RFC, I believe that was in 2019. In September of 2020, we posted an actual version 1 to LKML. We got feedback. It was primarily in 2 areas. The first area was the x86 area. The x86 maintainers pointed out these recent changes to the compressed kernel, where they're attempting to make it completely a position-independent executable. And what that means is that the executable cannot introduce relocations. But our code, not knowing that at the time, wasn't using relative offsets when addressing things through registers, and that led to us generating relocations in the during the linker phase. The code change to fix that and remove relocations has already been completed. It just needs to be prepared for the next version of the patch set. The bigger issue that came up was that we were introducing a separate minimal TPM driver in the compressed kernel and not using the mainline TPM driver. And the TPM maintainers wouldn't sign off on our doing this. And their suggestion was to refactor the mainline TPM driver to be able to be used in the compressed kernel. So we took a look at that to see how the feasibility of doing that, and it turns out that it would be extremely difficult because the early code in the compressed kernel has very few facilities that would allow us to use that driver. There are no timers running, there are no interrupts available. So like a lot of for example, the TPM code is tied to timeouts using jiffies, and none of that can be initialized in the compressed kernel. So any refactor of the mainline TPM driver would be incredibly difficult and disruptive and potentially destabilizing to that driver. And there's even the possibility that it's not possible. So the compromise solution we adopted, which is not ideal, was to take the measurements, but to postpone extending the measurement values into the TPM until the mainline TPM driver is available. So the early code before, for example, anything was used like the command line or boot params, we would still take the measurements and we would store them in the TPM event log, and then later we go read them back out of the event log when the TPM driver was available, and then extend them into the TPM PCRs. So the patch set for these proposed the patch set based on the proposal is in the works at the moment. We hope to have something for LKML in the not too distant future, maybe in late spring, early summer. And one other thing I wanted to mention, if we could just go back for a sec to the last slide, and one more slide before that. So you notice that the orange, the reddish blocks all say Oracle contributions. I just want to make one thing clear here. While some of the code was completely done by Oracle, other code was collaboration, mostly with Daniel Smith from Apertus Systems, and other code like the TPM driver, we actually did minimal contributions to. So I just wanted to make that clear that, while we have contributed to things, the amount of contributions varies depending on components. So like for the TPM driver, it was minimal for Oracle, whereas a lot of the other kernel parts, it was almost all Oracle. And then the uroot, rootfs, and security framework, that portion of it was, both Daniel Smith and people at Oracle working on that. And with that, I will turn it over to Patrick, and several slides forward, and have at it, Patrick.
Okay, thank you, Ross. My name is Patrick Cole, and I will be talking about uroot and the security engine. So as we mentioned before, and you saw in the diagram, the MLE kernel will, at the end of its operation, it launches the uroot init ramfs, and this is what contains the security engine. So what the purpose of the security engine is to verify that all the necessary bits to ensure that we're launching the correct target kernel and ramfs are done. So the main way this works is that the security engine is controlled by a policy file, and this can specify, amongst other things, collectors and measurements, as well as a list of valid target kernels and init ramfs that we want to load, as well as containing some configuration settings. We validate the policy file by using a public key and signature, and we validate the public key by comparing its hash to a value that we store in the TPM. The policy file can specify a LUKS key or several keys, and if so, these are unsealed from the TPM and then appended to the existing target init ramfs. The LUKS keys themselves are sealed against PCRs, and typically this would be something like PCR 17 and 18. And what this does is that ensures that only the MLE can unseal the keys and only if the platform configuration matches. And so all of this works together to give us a sort of a complete chain from launching into Uroot to validating all the pieces into ensuring that we are in fact launching the target kernel init ramfs that we want. So next we will see a figure of this. This is sort of a blow up figure of the init ramfs section from before. And we can see here that the flow is kind of what I just mentioned. We verify the public key using the hash in the TPM and the actual public key file. We then use that to verify the policy file and make sure the signature matches. We then run collectors if that was specified in the configuration. And this can be things like the CPU ID or specific files, or in fact, entire storage partitions. We then verify the kernel and init ramfs. And we do this by comparing their hashes to a version stored in the policy file. And then finally, we unseal the LUKS key and append that to the target init ramfs. And then finally, we will do an sexit and kexec into the specified target kernel. And so next we will see an example of the secure launch policy file. So here we can see, these aren't all the sections, but these are kind of highlight sections. So at the top, we can see that there's configuration options. So in this case, we're specifying that we want to do measurements, and these measurements should be stored into PCR 22. We've also specified one LUKS key entry here. And so we specify the index where this key exists in the TPM. We then specify the PCRs that we're sealing against. So in our case, this is PCR 17 and 18. And then finally, we specify the location where the key file should be written into the init ramfs. We also specify here some PCRs that we can cap off. And so what this does is we write values into the PCRs that are specified. And what that does is, so when I'm in the target launch environment, if I read the PCRs, I'm going to get different values than what we're using to actually do our unsealing and measurements and things like that. And it's just a sort of security precaution. Next, we can see our launcher section. So in this case, we're using kexec, which is currently the only supported type of launcher. And here we've specified two different valid boot entries. And in each of these entries, we specify the name of the kernel that we would like to boot. So we have a 5.4 kernel and a 4.14 kernel. We then specify the hash, the SHA-256 hash of the kernel, of what it should be anyway. And same with the init ramfs file. And this is what the security engine uses to validate the target kernel init ramfs. So basically it says, okay, this is the file I should load. I'm going to load it, take its hash, and then compare it to the value stored in the policy file. We trust the value in the policy file because that was signed using the public key. And then finally, we can specify the command line that we want to launch that target kernel with. And so you can actually specify the same kernel and init RD multiple times and provide different command lines, for example. So finally, I'm going to talk about the efforts to upstream all of this. So there is already some initial Uroot security engine code that is upstream. And then we've been building on this. And so we've included things like just general hardening of it, adding in the verification of the policy file, adding the injection of LUKS keys and things like that. And we're currently getting all of this ready to do upstream review and then ultimately push it upstream. And the goal of our upstream effort is centered around trying to provide as much functionality and flexibility as possible. We try to do most of this, if we can, through the policy configuration options, but we understand that in some cases, this isn't going to be sufficient for all needs. And so we're trying to also provide as much functionality as we can in a form of package or library type functions so that somebody can go and implement their own UInit code. And with that, I'm going to pass you off to Brian, and he is going to discuss upgrading the MLE.
All right, thank you, Patrick. My name is Brian Payne, and now that we have our secure launch capability, it's time to start thinking about how we're going to use it, and specifically how we're going to manage it once it's been released as a product. You know, all software has bugs, hardware has bugs, and there are many third-party components in the chain here that we may not necessarily control. So we recognized, hey, look, we need some mechanism for upgrade and recovery. We wanted to keep it as simple and as secure as possible. And we wanted to retain strict control over TPM ownership without exposing any of its auth values or secrets outside of locality 2 or the secure environment in TXT that we were discussing earlier. So what's our strategy? The key here to all of this is the platform owner authorization value. And so our strategy is to keep that as close to the platform as possible. So what we did was seal it to a special binary that we're calling the management MLE. This means that the management MLE is the only entity that can use that use that owner auth value, or even really knows what it is, to be honest, to manage whatever secrets we decide to store in the TPM. For instance, the LUKS key, as Patrick mentioned earlier. Next slide, please. So what does this mean? Well, if we had a single monolithic MLE, everything you see here would be in the same binary. But like we said, if there's a bug in that binary, that causes problems. So we split the functional components of that monolithic MLE into two binaries. One we call the runtime MLE and the other the management MLE. The runtime MLE is really just a very basic policy engine. It finds and authenticates the policy file Patrick was mentioning before. It loads and authenticates the follow-on operating system and performs any other operations that it needs to boot that OS. Then we just clean up and transfer control. Pretty straightforward. If there's a bug here, the exposure is very minimal. Yes, the follow-on OS can be tampered with, but ultimately we're not going to lose complete control of the platform. On the management side, we've built a special binary that does have the privileges it needs, but through special operational security practices, we can ensure that the exposure that the management MLE has is much different than what you would expect with the runtime MLE. We'll talk about that in a second. So what does the management MLE do? Similar to the runtime guy, it's going to find and authenticate its own special management policy. This is different than the runtime policy. If the management policy says to do it, the management MLE will unseal the TPM owner auth, update any TPM objects that need to be updated, forward seal any secrets that are in storage so that we can do updates to the runtime binary or the management binary itself, and then we'll clean up the secure environment and, most importantly, reset the platform. The management MLE never boots a follow-on OS, meaning the attack surface on the management MLE is much different than what you would expect from the runtime MLE. And we'll look at that in the next slide. Okay, so here's a picture of what the normal runtime MLE looks like. Sort of up at the top, left to right, you have execution happening in memory. And the bottom left and right, you have your TPM and your boot partition. And what you see in this diagram is that there's a bug in the runtime MLE, right? And it's
somehow, either through the binary, the configuration, or however, someone has gotten inside of locality 2. In a monolithic case, this is bad, because it means that person is now going to have access to the TPM platform owner authorization policy represented by that little key there. In our case, since we have split that functionality out of the runtime MLE, yes, that person inside locality 2 can affect anything that happens in the follow-on OS, but ultimately it doesn't have access to the TPM objects it needs to affect platform configuration. So the platform configuration will persist, even though the runtime MLE has been owned. Next slide, please. Okay, so now let's look at the scenario with the management MLE. Here, the management MLE does have access to the platform owner authorization value, and so it can indeed go ahead and update whatever it needs, either the internal TPM objects or the binaries of the MLEs themselves. And once it's done doing its update, it just resets the platform, right? SExit into platform reset. As you can see, this severely limits the ability of an attacker to get code injected somewhere in this process. There is no follow-on OS, there are no removable devices, no console, no network connection. And if we, like I said before, are mindful of our operational security practices, we can run this management MLE completely disconnected from the rest of our environment, further ensuring that an attacker would have to burrow deep inside the system in order to affect any of this functionality. Next slide, please. Okay, so here's a quick example of what the management MLE policy file looks like. You can see we further simplified it from what Patrick showed before for the runtime MLE by converting to a simple CSV format. This removes the possibility of parsing bugs or severely limits the possibility for parsing bugs and makes parsing the policy file much simpler. You can see here that we have expected hashes for the current management MLE and then hashes for both new management MLEs and runtime MLEs, as well as their associated policy files. Next slide, please. So again, benefits of using a management MLE. Normal boot compromises, normal runtime compromise doesn't result in total platform compromise. If you have a monolithic binary, that's not true. The TPM owner authorization value with the management MLE is never exposed to a network or OS adversary. There is no network, there is no OS. Each platform gets unique secrets. We can literally store a unique TPM platform owner auth value on every platform, and we don't have to escrow and by implication protect all of those secrets in a centralized directory service or database, which is huge for an enterprise. The runtime MLE and OS components are very easy to update or recover. We're really just talking about dropping new files on the boot partition and rebooting. And hopefully attacking the management MLE is very difficult, or at least as difficult as possible, especially if you observe good operational practice and perform the update while disconnected. Next slide. So future status. The management MLE and runtime MLE today pretty much share the same code, especially with respect to the Linux kernel. There is tremendous opportunity actually to minimize the management MLE code, which would only further reduce the attack surface. And this is something that is on the roadmap in the future. Going forward, once that's done, the changes will be limited basically just to the uroot security engine. further differentiating the functionality between management and runtime. And having a working implementation, we have a working implementation, and will upstream these changes with the runtime MLE changes when they're ready. Next slide. So that concludes the presentation. On behalf of Daniel, Patrick, Ross, Kant, and myself, thank you very much.
All right, thank you. Is there any questions for Oracle at this point? All right, if not,
I believe that.
Oh, go ahead.
Yeah, Daniel, there was some comments from Christian on Slack.
Okay, apologies, I missed them. Go ahead and ask.
Yeah, I'm not sure if this is a question. This is more like a comment. I'm not sure if Christian can join with the voice, but it's a comment about extending PCRs from event log. So, and he's saying like it sounds like it's a terrible idea.
So yes. So I see what his comment is about the fact that since it's in memory, it's mutable. So I had some discussions with some of my colleagues about taking this approach when we basically came to the conclusion that trying to do the alteration of the TPM driver that we were being asked to do was not within the scope that we were trying to solve here. So when I was discussing with them, the point that they had is the fact that the kernel is still in positive control of the system, and so you haven't changed what had control of the system that took the measurement and when it extended. So all you're doing is extending the time from when it's taken to when it's actually sent. This is where we talk about how it's not ideal. The ideal solution is to basically send them to the TPM as soon as we take them. But at this point, the stance of the TPM maintainers was that we either had to reuse their driver within the compressed kernel, and that was pretty much it. There was no ultimatum. They basically said we had to refactor their driver to fit in the compressed kernel, and Ross kind of covered over some of the points of why that was going to be too difficult, and so this is the best we can do without a TPM driver present in the compressed kernel. I don't know if Ross wants to comment any further on that.
One thing we've discussed is carrying a patch for now to let people switch it back to the better way. If you don't like that solution, unfortunately, won't be able to upstream that right now, but at least there'd be a patch to let you go back to the original mode of doing this. Yes,
we will maintain a fork, ergo a patch that will keep it as it is. So that way, those that want to leverage what went upstream, they can. Those that are willing to accept the patch to have a stronger position could do so. Okay, we're now into the open discussion period. So we are actually open for any questions or comments or any areas you'd like to discuss over what TrenchBoot is doing, DRTM, TPMs, any of that we're open to. So I'll open the floor to general questions at this point. Okay. All right. So if I don't have any general questions, I'll ask some. So Piotr, so far we've been doing this for a couple of years now. I mean, do you have any thoughts to reflect on these past few years? Perhaps just things you might do differently, in hindsight. Any thoughts?
I think the answer is, this is Conrad from Oracle. Everything is great.
Yeah, apparently everything is perfect, right?
Patch is welcome.
Yeah, patch is welcome. Yes. So, well, Andy, since you're on, in your time, I mean, any thoughts that you have?
Not specifically. I think when we get around to doing the Zen equivalent of this, we're going to not do what Linux is insisting on for the TPM. That seems like a recipe for disaster to me. I'm sure we can find a way of doing it that is rather more secure than that.
Yeah. That, I mean, I get the standpoint that they don't want two independent implementations of a TPM driver. The point of view that I take from that is that, that we were talking about a minimal implementation just to do enough to send measurements. We did not implement an entirety of everything a TPM could do there because we didn't need everything a TPM could do there. And so, but unfortunately, that opinion wasn't acceptable. So.
Yeah, so Daniel, I started to answer your question. Of course, I had muted microphone, so I talked to myself. But what I want to say is, this sounds like a provoking question, but when I'm looking at various other communities built in short time, I really appreciate what Richard Hughes did for FWPDF LVFS. And they're growing, they are in firmware realm, they're touching firmware stuff. They are very, they had a very hard task because they had to talk with major players and convince them to themselves, convince to the service, and gather all this, build everything. And to be honest, I was there at the beginning of the project, and really a lot of things didn't work. But step by step, Richard made a community, and I really like how he's approaching building the community. And knowing him personally, he's experiencing that. He's doing that another time. So he's sent by Red Hat. First it was for some other I believe glib related projects. He has some past projects he spin off in community, and now they gave him something more ambitious, and he even spin off that one. And I believe we can look at how he's approaching spinning of the community, and that's related to my previous question, how we envision sponsorship of the development of TrenchBoot, because, and you said corporate organizations have their own roadmap, but then we have these gaps. So corporate world has roadmap, of course, that's fine, but how does it hold the space? And we have other realms. Yeah, we have smaller organizations. Even you maybe are somehow associated, but then 3MDev, maybe other companies would like to jump in. Those companies also have to create either products, either there have to be some consulting related stuff which will move forward. And you can see that, for example, if you look at FWPD LVFS, you have section consulting. And by the way, this section was created because we talk with Richard, various companies talk with Richard and say maybe someone will try to enable LVFS FWPD for their platforms, for their laptops, Linux-based laptops, or for their peripherals, and maybe you will not have time to support them. So why not say this is list of consulting companies which can help you in enabling that? But on the other side, Richard also have this good guides, good documentation with explain canonical demos and canonical use cases, and someone can really test things. And I believe many times we as a Trenchboot community were get complaints that like, what is this? Like, how I can use that? And what's the canonical demo? What's the canonical example? How it compares to Secure Boot, and so on and so on. And I believe if we will be able even to gather the materials we already did over the last 2 years, and just do like order that in a maybe more approachable, easier consumable things. Maybe this would explain to people, okay, how this can be used, and then maybe there will be interest to build this community, build the needs of other players, of other companies, which can sponsor moving that forward. And finally, there are also end users and developers and hackers who may want to enable that for themselves because they are curious, they want to learn, because they want to improve the security of their open source ecosystem. Yeah. So I believe there are some examples we can follow. Of course, everything is about resources. I know you don't have time for that, but maybe as a community we can at least say, okay, I can do some small thing here, I can do some small thing there to move into that direction of building healthy, public project or open source project.
Right. Yes. So I've had a few of those discussions, right, on that topic of, I guess I would term it as outreach. Right. Both yourself, myself, Daniel Keeper, Brian, we've all done presentations trying to get the word out there. But yes, so that was part of the reason why we pulled this together, right, is to help kind of explain what Trenchboot is. And I think the follow-up from this is to start focusing, in a measured way, start focusing on building up the website further, right? We have lots of documentation out there, but the effort's more on the end user to have to go find all of it within our repositories. And I think maybe if we do some work on the website to help promote some of these things that you're talking about, the canonical use case, the canonical demo, how do I get, quick starts and things like that, right? We definitely need a lot more improvement in that area, which goes back to, right, we're out here trying to say, come help us. We need more resources to get that done. Now, in terms of like corporate sponsorships would be a great way if we could convince somebody to help fund us a full-time person to go off and take care of this stuff, right? That would be huge. Otherwise, it's back to those of us trying to build a product as well as evangelize about the capability itself that uses that. So yes, it is definitely an area that we need to work on, right? So I don't. Does that help with an answer, or do you think there's more that we need to do?
Definitely, there's more we have to do. But yeah. So I understand your position.
But in terms of first steps, right? If we start moving in that direction, do we think that would help a lot?
So I have some suggestions.
Sure.
Can we create a portfolio of attacks on non-DRTM launch integrity solutions?
Yeah, we can start with like the latest one. Start with Boothole 2 and just start working your way back to all the breakages of, breakage of BootGuard, the breakages of Secure Boot.
So I don't know, like, what's this acceptable pen tester framework for launch integrity. I mean, is it modules of Metasploit? Is there some other framework? But if you can basically turn every pen tester into a salesperson for DRTM because they break all the non-DRTM solutions, that'll get attention pretty quickly.
So I believe one path is ChipSec. So definitely ChipSec is framework which is used to verify some basic protections related to SRTM. I know that also various stuff was checked by tools delivered. So Alex Matrosov, for example, on Black Hat, he showed these slides. I also use that methodology, exactly the same methodology, showing that SRTM is complex and what kind of problems it has associated.
Well, you know, it's not just that it's complex. People, decision makers who are not technical and technical people who are busy are all overwhelmed. Every single person, every single day is basically being pitched by a different website with a different logo about a different thing to be worried about. And today there are no logos and there are no websites scaring anyone into trench boot. There is no known problem for most people for which trench boot is the answer. Now we know, the community, the people working on it obviously do, and probably have seen real world attacks, which are not public, right? Which is why this work has been done. And so arguably Microsoft has done more than anyone in the last 2 years to evangelize this, but their work is still being rolled out. So it'll be like another 2 years before the Microsoft marketing machine really starts to teach everyone what the problem is.
Well, I mean, right, so there's the Octagon team, right, from Microsoft, and that was in 2018, right? In which they basically walked through all the problems with SRTM and why Microsoft was moving to DRTM for what now is called Secure Core.
Absolutely. But you know, Microsoft has a huge install base, right? And then the Azure stuff is new. So it's just a very big ship to turn. And it's turning in the right direction. But in theory, you know, open source folks can turn faster. So I feel like we need a offensive campaign, even if it's just a roll up. Yeah, something, you know, evil boot. There just needs to be a tool set. But the key is it's got to be usable by people who are commercially paid to do pen testing. Because that way, if they just roll to their standard tool set, then every report they file to their paying customers is going to be like, hey, you've got this problem. The second thing is a lot of this is tied to hardware integrity. And we know that, you know, a lot of platforms, most platforms that are not embedded today get abandoned from a firmware point of view. Like, to really get a fix into firmware, you got to have a really major problem, right? So many devices people are using today are not secure. Now that is very bad for the customers, but it's actually very good for the OEMs who we're trying to get attention for. Because if you look at, take an example, look at Apple's iPhone, right, where the boot ROM was broken. I mean, on the day I found out about that, I just went to the Apple Store and paid whatever they wanted to extort from me for a new phone. I had no choice. So there are actually a bunch of people today running on hardware that they should be immediately replaced. And that isn't well understood at all. Because people, I think, don't want to face the reality that, you know, X millions of dollars are actually poorly spent. But so that's a marketing thing. It's an acceptability thing. You have to kind of hold, you know, decision makers' hands. There's just a lot of work here, basically, on what I would say is the demand generation. People to understand why they need these types of solutions. Where you're basically saying, we're going to have owner-managed keys. We're going to have, you know, software acting in well-controlled ways, and there's things we can do in the software. And then where we are, depending on the hardware, we got to put a very, very bright light on it, right? Yeah. So if you get something in the chipset, it's got to go into every OEM before they ship the hardware. Basically, every vendor, every buyer in a large enterprise should be able to say, I am not paying $1 for this laptop or this server until you show me this chipset version passed.
Hi, sorry. Can you hear me?
Go ahead.
Go right ahead.
It's first time in this forum. I am Dario Oliver. I go by Nico. So I am an Intel employee, and I mostly work with the TPM-based technology, secure boot, and starting to work with this TXT, mostly around T-boot, right? So awesome. I do customer engineering, and what you have been mentioning, it's completely what I see today. So there is no understanding of what a T-boot, TXT, trench boot does, and what are the benefits to them, and why they should care about that. So it happened the same with the TPM and the firmware update capabilities. So the approach that worked for me and the customers that I support at least was to work with the firmware update manager project. So they have all the firmware update capabilities, which are great, but they also run this initiative about host security IDs. So what host security IDs basically do is run a minimized version of ChipSec that can actually be understood by not a security researcher, so it's much more user-friendly. So there you have checks for secure boot, for platform keys, for TPM availability and all that. So what helped me to promote these tools was to add test into the host security ID for the technologies that we were interest on the people that they should be aware of. For example, the version of the CSME engine, right? So today checks that and it notifies if you have a version that is vulnerable. So what I think it can be do with like TXT and dynamic root of transfer measurement is to add a test in the host security ID specification for that. And became aware if somebody has the capabilities but is not launching a measuring launch environment, or if it doesn't have it at all, then they should look into it for the next hardware selection, right? So that is more user-friendly than ChipSec. I mean, ChipSec is more for security researchers, right? But it's something that worked for me at least, and maybe can work here as well.
What's the how would I find that with the web search? You said host security ID.
Yeah, it's HSI, host security ID. It's on the firmware update manager repository in GitHub, I believe. So it's very simple to run analysis. I work a lot with Fedora and Red Hat based operating system, and if you're using Fedora today 33 or 34, then you have the tool enabled, and the tool works with secure boot enable in contrast with ChipSec, for example. So ChipSec require you to install like kernel modules that are not signed. So if you have secure boot, then you cannot do that. So I think the HSI is much more, has a broader audience than ChipSec.
Do you know who does Richard maintain that? Is it?
Yeah, it's Richard Hughes, and with external contribution, from person from Intel or from other guys as well. There's mostly one person from Dell. It's Mario Limonicello, who also contributed a lot on that. So it's pretty active, but I was expecting by today to, it's like a development feature today. You have to add the minus force to run that. But I was expecting by today, it has been 6 months over that we are using that. It should be something that is, run by default by the firmware update manager. But there were a lot of problems around how hardware behaves. So there are lots of problems with event logs and how different versions of stuff reports, like how bootguard and BIOS log is enabled or disabled. So it's kind of it's still not 100% reliable on some platforms, right? But I will say in Dell, at least in Dell and Lenovo laptops, that will, I think it approaches 100%. But if you're running something that it doesn't know, then you may have some false positive, maybe.
Okay.
So
sounds very, very promising.
Yeah. So one thing I think, because I know I'm guilty of this, not intentionally, but This what we should be focused on is not making this an SRTM versus DRTM competition, right? I think that's one of the things that Microsoft actually did in their paper, which is that they said SRTM has all these issues or these shortcomings, but they didn't say just throw it away. They said that DRTM comes in and helps fill these gaps, and it's that understanding that I think it has been lacking in the decades now, right? That TXT and DRTM has been out there. People view it as there's the discussion of the gap, right, in the old TCG documents, and the purpose there is you're trying to deal with the gap, not to replace everything because you can do this late launch later. So I think that's one of the things we need to kind of be mindful of as we're out here evangelizing for DRTM, is that it's not something that replaces our SRTM, but it's something that complements it.
Yeah, I actually agree with Daniel with you, and even I had an opinion that DRTM cannot be a replacement for SRTM, so they should work together. So I think that it is a good point to say that they are not competing technologies, but they are complementary, as I understand from various discussions.
Yes. Yeah, right. It's specifically, right, we want the SRTM. The SRTM tells us what set up our platform, right? What firmware was used to configure the hardware on power on and everything else. We should care about those things. I think the flaw that happens is that people think that they can use the SRTM continuously forever, and that's not the case. That's where you need the DRTM. You need to, at later times, establish what the integrity is about your system. And so, and like I said, I'm as guilty as about that, not trying to do it intentionally, but sometimes the way I phrase things, it comes off that way.
Another issue I think that we should discuss from technical point of view is how the TrenchBoot project should cooperate with UEFI. And I think that there is still unsolved and not much discussed. I think the problem how to utilize UEFI runtime services from maybe not MMLE, but OS, which was started by the TrenchBoot, I think, infrastructure. So at this point, my understanding is that we should not call UEFI runtime services because we do not trust them. But with our UEFI runtime services, we are not able to do a lot of. We are not able to do a lot of things. For example, we are not able to update the firmware. We are not able to change the boot order, etc., etc. So I think that we should think how to solve that problem. Maybe this is not the most important at this point, but I think that we should start discussing how to approach this problem, I think.
Right. So I've talked about this before. There's a couple of ways that could be handled, right? One way is to be able to remeasure firmware, right? When a DRTM launch is done, if we can reestablish that the right firmware is still in memory, then that means we can have the same level of trustworthiness about the operating system we loaded as we have about the firmware, right? That's the whole thing that I keep talking about between launch time integrity and runtime integrity. Those SRTM measurements told you what firmware was loaded in memory. It doesn't tell you what firmware is still in memory when your operating system finally gets control of the system. Because lots of I/O devices, lots of PCI devices have now been talking with that firmware, and you don't know what happened. Unless you have perfect guards on all your devices, you don't know what they did to your firmware. And so,
sorry. Go ahead.
Yeah.
Sorry.
Yeah. So that's why when we do a DRTM launch, we talk about not wanting to make calls back into runtime services, is because we don't know what's there anymore. They weren't part of the root of trust that we established with the DRTM. Now, with the inability to remeasure them at this point, the other way is that you can actually use a hypervisor to constrain access, right? So whatever is going to make the calls into the runtime services, run that in a constrained VM, so that a way you can minimize what the firmware could do, because the calls in the firmware should be constrained to the VMCS or VMCB, depending on whether you're on Intel or AMD. And I'm sorry, Daniel.
I think that is good ideas, but I think that it requires a lot of work with firmware developers, and I think that maybe it also requires something that some things should be standardized. For example, UEFI spec, because I think that at this point, for example, we are not. It is at first sight, it seems to me that it is almost impossible to measure the UEFI runtime services. Of course, we can to some extent look at the runtime service memory regions or something like that, but I'm not sure that this is an easy task at this point. I think that we should start working with folks from UEFI forum or something like that and discuss with them how to do that properly, I think.
Yes. I mean, at the end of the day, the root of this all is that as long as you have software that's in mutable memory, then after some period of time, you don't know what's there, even if you've measured it when it got loaded. So either runtime services need to be executed out of immutable memory, such that what was loaded can't be changed after it's been loaded. That's where you get into the discussions about cherry, capability pointers, kinds of architectures. And then if you can't get to that, then at that, you have to do something to be able to reestablish the integrity about the firmware.
And to be clear, you're never going to get an EFI runtime service that can run fully immutable, because by definition, it's got state it needs to change.
Yeah.
Yep.
So you're never ever going to be in a position where you can remeasure the EFI runtime services after the fact. Whatever we do to try and secure them will have to be something else.
I wouldn't make that strong of a statement. I would say that it is a very difficult problem that requires a level of research to be done before you could achieve it.
I think that the simplest, rough approach could be to split the UEFI runtime services into the code and data. This would be, of course, a rough approach, but maybe this can be a good starting point for this. But of course, this requires a lot of discussions, I think.
I just want to say that workaround in UEFI problems is just it's not just by solving their complexity in Trench Boot, but you can just stop using UEFI, and that's also a solution. And to be honest, it's not so. I know that sounds funny in this situation, but I'm pretty sure in 2-5 years this would be less funny and will be more reality, because we already see a lot of traction in the server market, especially through OCP. And I believe sooner or later there will be server platforms which are shipped with Core Boot or Linux Boot or whatever. And maybe this runtime services problem would not be a problem in some time.
But do you expect that UEFI will die in the near future?
No, it's not. I'm not like, I'm just saying.
It's not. The world we're going to is a color-coded world. Reality is going to be color-coded everywhere you turn. This is a blue device. This is an orange zone. This is a red plane. This is a green laptop, right? So, and the highest security data will be color-coded and will only be allowed to run on the highest security platforms. So it's not that everything has to be non-UEFI. It just needs to be that some devices exist which have enough. It doesn't have to be fully open, right? But enough of the critical pieces should be open that people who evaluate security say, I'm going to give that device and that configuration and that supply chain the highest color, and therefore it gets to open the most important files.
So even like looking from the perspective of evolution of the firmware, so why we have all these problems right now? Like we have a lot of the problems related to firmware because it's the supply chain of it is in special way controlled, especially for server. But we already see that there is change there. Already the vendors of the silicon vendors already changing the approach of delivering the initialization code. And if this will change, it will open the window for creating alternative paths for the firmware. And for example, if someone would like to solve the problems easily, they maybe will just avoid the UEFI and the problems will be solved. If they don't need, for example, some capabilities, or some capabilities will be very hard to satisfy, like this runtime services measurement and this kind of stuff, which is, in my opinion, very hard problem. And it's hard to imagine how this can be solved without interaction with UEFI forum and changing the spec. Or maybe someone have, I don't know, Andrew, maybe you have different ideas how to approach that. But that's probably the easiest thing to change the way things going on in the spec. And this will take years. This will take years.
Yeah.
Right.
Like remember, like we're at an amazing inflection point right now. Like right this second is, for years we talked about ARM, and ARM is not standardized. And then just in the last 6 months, right, Apple M1 launched and has completely overturned user expectations of battery life and security and usability on a portable device, right? So now it's going to be hard suddenly, all the Intel customers have to have their expectations change. And so since the Apple M1 founding semiconductor team has just been acquired by Qualcomm, and Qualcomm is going to ship ARM SoCs for laptops, and Microsoft is going to do DRTM on ARM, right, with Qualcomm as a partner. It means you have suddenly ARM devices looking like x86 devices, which are going to try and implement UEFI to be compatible. And somebody, probably Qualcomm, is going to write those specs. So they have the opportunity to tweak the UEFI implementation or even fork it, because the number of ARM UEFI devices is going to eclipse the number of x86 devices just because of IoT.
Yeah, I assume that the standardization of ARM boot process, those SBBR and those specs that they trying to create, those are closely related to what you're saying.
Right.
Yeah.
But what I'm trying to say is, like, it's a once in every 20-year event that's occurring right now. So whatever you guys want to see change, now is the time to write it down and beat the drum.
I would like to identify the Qualcomm device which has the RTM capability. As you know, we know, like, it's on Microsoft website that there is Qualcomm device, some Qualcomm device that has this capability. So question is what it is and how to know about it, and who can learn more about that, because that means we can extend the scope of the trench boot through another platform, through another case, and maybe look at the ecosystem from different than x86 perspective, which should probably help us shape how things should look like, because we are poisoned with x86 perspective.
So it's true that you should. It's true that when a big player, turns the ship around and starts to fund the first version of DRTM on ARM, absolutely, we should all take a look at it. At the same time, we should have some open stack, right? Just like Trench Boot is a relatively open stack on ARM that the open community is pushing as well. So it's a negotiation between the big guys and everybody else. So if it's an opti, some kind of opti code that's open source, it's running in Trustzone, that is trying to integrate with something in TrenchBoot, that would be a thing.
Mm-hmm.
I think Daniel thinks something like that is possible, right? At least in theory.
It's more than I think it's possible. I actually have a working concept, I'll say, around that.
Mm-hmm.
So
you're not working for Qualcomm.
No.
Okay, that was not the question. Like you don't have to answer.
Yeah, yeah. Well, the problem is that there's things that I've got brewing, and then there's things that I've got near term, and so that's much further down on my roadmap of things to produce. Doesn't stop me from kind of working out the mental model behind how it all will work and everything else. So
there's a great, every time you go to the Silicon Valley and talk to some startup person, they're always beating you around the head with the innovator's dilemma. And basically, that the toy technology, if it gets enough volume, can overturn the enterprise technology, right? And so the toy technology for IoT is the Raspberry Pi. And the volume has become so dramatic that a lot of enterprise stuff is prototyped on the Pi, and Pi is the definitive CI system, right? So if you wanted to get TrenchBoot widely adopted, you should get something that works on the Raspberry Pi, so that the interface, and I know the implementation, the mechanism is extremely weak, blah, 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 but it doesn't matter, right? If the code they develop on the Raspberry Pi can later then run on a Jetson, more expensive board or an automotive board, it gives you what you need. It gives you that toy audience, a huge audience.
Mm-hmm.
I totally agree with Rich there. One of the long-standing frustrations is, how do I get started? How do I get something to work on? How do I get something to tinker with, right? To understand how it all works.
Yes.
Solving that problem, I agree, go a long way.
Yeah, I mean, I really believe for about a year, Intel was going to put, it was going to enable TXT without vPro on the Jasper Lake, the Atom's CPUs. And they did put it in silicon for Tremont, but they left it out of, they only put it on the 5G SKU, which is like $1,800 or something. So it's probably a business decision, not a technical decision. But since they haven't done that, we got to find something else. So right now, the next best thing is the APU2, right? The AMD or any AMD low cost device. The Ryzen is like 300. The APU2 is 150. But Raspberry Pi, man, that's like it's under 100. It's $50.
Yeah, depending on which version you get. Yep. Yeah.
The other thing is the Raspberry Pi apparently has something called ThreadX, which is a little microkernel running.
Well, yeah. Do we want to get into that discussion?
Well, that would be some fun stuff. It's part of the boot, It's part of the boot. Like put a fake interface in there, treat it like malware, and have it talk to TrenchBoot. It doesn't matter. Like just get something working that checks your integrity.
Yeah.
And same API.
I fully agree. I mean, it would be amazing if we could actually inject something in ThreadX and put it onto the into the GPU execution that starts up the system, right? That is one of the most innovative things Apple did so far in terms of security, is actually doing the way they did their security engine, right?
A separate processor.
A separate processor, not a spy interposer, a separate security processor that can inspect and make decisions.
Yeah, I mean, look, people are trying to reverse engineer the ThreadX on the shipping Pi, and the ThreadX code itself is open. It's just that the version that's open is not the same as the version that ships in the binary blob of the Pi. So I think it'll happen. It'll get there. And when it gets there, go ahead.
Yeah, there is this Raspi internals mailing list. It was dead for a long time, but recently it's like getting back to form. I guess it was dead since May 2018. And recently get some activity. It's about Video Core 6. VPU and PPU and like all the things internally. And yeah, I believe the people still trying to do something, to execute something on the graphics card.
So if we're doing action items, maybe one action item is that the front page of the TrenchBoot website should have, just how do you get started today? Here's the machine you should buy. Just step by step, 1, 2, 3, 4. First thing, right on the front page.
Yeah, if we're talking about this kind of approach and starting to fill in the gaps, like 3MDEP, we have very little resources, but we can spend even those, like some small resources of people who can write blog posts or some content. Maybe this would not be like tons of stuff in 1 week, but month by month we can have more and more. Of course, if we can like align the roadmap for doing that stuff and everyone contributing, because if this will still rely on one party, that doesn't make sense.
Yeah.
But I'm completely open to provide some resources from 3MDEPs.
Yeah, I think we probably should set up a time to those that want to work on the website or want to have input on what we do, and just have a dedicated meeting on discussing what we want to do for the website, and get some ideas pulled together, and then that'll we can put that onto the roadmap, and we can work those items and give the website a refresh.
Yeah, so some of you know that we're doing hostboot port to coreboot for Power 9, and we have a regular every 2 weeks call when some people from community just jump in and give suggestion, help us, and so on and so on. And this works quite well, I believe. At least we can inform whoever we need, and we can think across the board of the people that are interested. So So the same stuff for TrenchBoot would be great, but it's, I don't know, Daniel, it's up to you how much time you have.
Yeah. So, okay. Anybody else have anything they'd like to discuss? No. Yeah. So I think we're kind of hitting towards the end of it now anyway. So Andrew Cooper has been kind enough to host a virtual pub for us, for anybody that would like to join, to just have an off the record casual conversations. For those, I'll try to get everybody the link. We're going to post it on Twitter here in a moment, so that way anybody that wants to join can come join us. So in that, is there any parting thoughts on any of the contributors before we close up? I mean, Kanth or anybody from Oracle side, any closing thoughts that you guys might have?
Well, I think one of the questions is, was this useful? Was the event useful? Are we going to try and get other people to use the content? Where to promote the content?
Yeah, that is a good question. I mean, was it useful?
Yay!
I think that it was very useful, because it during the last 3 years, of course, we tried to present various topics in various places, but this time I think that we got together in one place, and all people working on the most involved in the project, not all, I think, but most of all people involved in the project came together and presented all things which were happening in the project in one place. So I think that from that point of view, it is a very good event, and I think that maybe it would make sense to make it happen more often, for example, twice per year or something like that.
Yeah, that was actually on. Oh, go ahead, Brian.
Oh, I was going to say, following on Daniel Keeper's last statement, something we didn't really even touch on is attestation, right? Or providing evidence of security goodness that comes from TrenchBoot. That might even be a topic for a follow-on.
Yes, definitely. I think so. Piotr and his team's has their demonstration with Chara, right?
Yeah.
Go ahead.
Yeah, and we're planning to do more things related. We're putting together some inquiry for grant from NLNet to do this offline attestation using Chara, and we will see like how this. If we will get the money, then we will move forward this stuff. I believe like the question is if we agree on like we can continue this discussion to virtual pub and there we can dive deeper into that because I believe this one is recorded and further one would not be recorded. So maybe yeah.
Yeah, and I mean even if there's a discussion about the various industry initiatives around attestation, right? I wasn't familiar with Chara before today, so that's been a nice learning for me, so I appreciate that. But it seems like there's quite a few of these things starting to bubble up. It would be interesting to see where everybody is on, the different approaches and standardizing on, data formats and that kind of thing.
Yeah. So, and by the way, Andrew Cooper posted in the Zoom chat the link to the virtual pub. So everybody that's on the Zoom chat, you should be able to just look in the chat log and you should see the link for the virtual pub.
Maybe it should be also posted to the Slack. So
yeah.
From Slack
yeah.
as well.
Yeah. That's
so
good.
Peter,
Good point. Thank you.
Do you have any documentation on Chara?
So Chara is done by Fraunhofer. Oh, go ahead. Go ahead, Piotr.
Yeah, there is this. Let me quickly just paste the GitHub. It's quite well documented. There is this link and Chara 3MDEP. You will probably find our article where Norbert did quite good work describing how we use it for. But I'm looking for this quickly, but just a second.
Yeah. So while he's looking that up, so yeah, so Chara is coming out of the IETF RATS working group, which is trying to standardize attestation. An attestation. I don't know if I want to call it a protocol. They're basically building off of the Java's JSON web token and basically standardizing a set of attestation fields for those web tokens so that a way you can format again, right? So it's a format, standardizing on an attestation format that could be used by a variety of attestation solutions, not just TPM based ones. They're trying to keep it open. So
yeah. So I pasted the messages.
Yeah, got it. Thank you.
Yeah. Okay. So any more closing thoughts from Oracle? Can't? Nope. Okay. How about Piotr? Any closing thoughts from your team?
No, I'm fine.
Okay.
Michał, Norbert.
So Daniel, I was going to pretty much the same thing what Daniel Keeper has said. Like I was saying that this was very helpful and it would be good if this could be done like on a yearly or half-yearly basis and keep abreast of all these attestation and technologies as well as these DRTM technologies.
Okay. All right. Thank you.
With all the effort you put in to bring this together.
Okay. Thank you. All right. Sorry, Michał or?
I'm good. Nothing from my side. Thank you.
Okay. All right. All right. Well, on behalf of myself.
Sorry, Daniel. Before you wrap up, would Luke? I don't know if Lucas is able to speak. I just want to thank him for joining.
Yes.
And for posting about the Trench Boot event to the T-Boot mailing list.
Yes, I'm able to speak. No problem.
Great. I'm just first of all, I'm really happy that Intel is participating in the Trench Boot project. I don't know if you had anything you want to say about, what we should do better, why you're interested, just anything at all. It's very interesting to have Intel participate.
Okay, so from Intel side, we are going to still support T-Boot, of course, but we are open to try some new approach. In my opinion, and also it's not only mine, but the opinion of other T-Boot users, T-Boot has some limitations that cannot be fixed using the architecture that was chosen for the T-Boot. That's why Trench Boot opens few more functionalities it will be not possible to achieve with T-Boot, and that's the main reason why Intel is interested to support and to be engaged in T-Boot project, in Trench Boot project.
Right. Okay.
All right.
Right. Awesome.
Yeah. Excellent. Thank you so much. All right. So I guess, Rich, do you have any closing thoughts?
I think the main one would be I would encourage. This is great events, right? I think at least maybe every 6 months. I think it would be good. I don't know if we could afford every quarter, but it was very useful. I would encourage the beginning of the event to have a slot for a warm up slot. A bit, here are the benefits. Here's a pitch for the non-technical folks. I think it would. Because this is fairly advanced material, and you guys jump straight into it, which is good for. And I know it's the developers forum, but there isn't really a Trench Boot users forum, so it's a bit of both, right? It's an advocacy event.
Yeah, that's a good point. Andrew, Andy, did you have anything you might want to share before we wrap up?
Not really. I think
Okay.
I've butted in when I've needed to.
And I understand. I just wanted to let everybody have a chance to any last parting thoughts. So at least on my behalf, thank you so much to everybody that's has helped with Trench Boot in contributions or otherwise. For me, it's very exciting. It's probably the first project this size that I've been involved with like this. And yes, the purpose of this was to start a recurring event. So whether it's in 6 months or in a year, yes, I'm definitely planning to have another one. And hopefully I will see everybody there at the next one. All right. Thank you, everybody.
Thank you.
Thank you for organizing, Daniel.
Thank you.
Thanks, Daniel. Thanks, everybody.
Bye.
Bye. I think at this point we declare the pub open. So
Yep.
Anyone who wants to switch over.
Yep. Virtual Pub is open. I'll post in the link on Twitter in a moment as well.
Thanks.
Thank you.
Thank you.